Okay, in this presentation, I'm going to give you a very brief, high-level overview of what the internet is, what the web is, the World Wide Web, or web for short, then how front-end and back-end fit into this picture, so that you have like a good understanding of, you know, how this all is going to work and what we're like dealing with in this front-end curriculum. I will try to make it as, like simple as possible. This is just like a very high level, simple overview. It's nice to have like a simple mental model for these things. And of course, we can get more technical and get in the details. But it's nice to have like some kind of like picture, as you will see here. Um, Okay, I will start first by describing roughly what the internet is in a very simple manner. So I will just use some computer icon. Let me make it like big. So internet, whenever we want to talk about the internet, we have to talk about computers. Okay, these are some icons about, I hope you can see them, like computers. So it all starts with computer networks. So we have computers, and then the really nice, cool idea that came about a few years ago, or a couple of years, a lot of years ago, was to connect computers together so they can communicate with each other. So it all started with computers and then connecting computers together. So let me connect like, let me just use a different like connector. So we have like, computers connected to each other. And then we can share, of course, documents, data between these computers. We can use like, we can share data between these computers. So this was a really, let's say, nice idea. Let's make this. And then from computer networks, like from local, like small computer networks, for example, computers connected together in a company, in a university, in a classroom, or maybe in a room in a university department somewhere, we got to the idea of taking these local computer networks and connecting them together. So let's say this is a computer network that lives in a university in Pennsylvania, and then there's another, I don't know, university in Istanbul, and then there's another university in Zurich, and they have these connected networks. And the idea was to take these little, let's say, local computer networks, or like small scale computer networks, and connect them together. So let me see. Let me grab like, where is this? Let me remember the shapes. So let's say we have this. Let me send this to back and just have like a nice outline. So we have this computer network in a, I don't know, in a university in Pennsylvania, and that's bigger. And then we have another one, in Zurich. And let me just, no, let's put them in this box so we can see these. So we have these computer networks, and these are called local area network because they are kind of like small and local in terms of the where they are like to be found on a university, on a department, or so we have these local area networks, or LAN for short. So just a bunch of computers connected together either wirelessly or through wires, and they can connect and they can share data. So you have this local area network. So the idea was, since there was like a lot of like research going on, and universities wanted like to connect to each other and share some data, some studies, some research. They said, okay, why don't we connect these uh, uh, local area networks, these computer networks together, much like we connect computers together. Let's like just connect networks together. And basically, this is how the internet was born. This is just an idea, the basic idea behind the internet, the network of networks. So we have small networks, and then we connect them together. So basically, we got like the internet after this. Um, and then it all started. So the internet, the way that you want to think about the internet is like a basic infrastructure where we have computers and computer networks connected together and be able to communicate with each other. So it's basically like a communication infrastructure, a way to connect computers and digital devices together and just let them share whatever data they need to share. So it's an infrastructure that lives on the low level, and it's just a connection, let's say, mechanism to connect computers together. Now, these days, in the beginning, it was about connecting networks together, hence the name internetwork. But these days, we have just every single digital device or computer, either a laptop or a desktop or a smartphone, which is actually a computer, connected to the internet. So we also have devices connected to this internet. It's not just networks connected together, but also devices. So we have like smartphone that can be connected to the network with all these other, let's say, devices or um, computers. And of course, we can have like single, device connected. So it's not only about networks, but generally every single computer on the world can connect with any other device or computer. So that's the internet. And if we want to have like a real life analogy with the internet, so we get a better understanding of not only the internet but also of the World Wide Web, which I'm going to be talk afterwards, is you can think of the internet as the, let's say, the transportation infrastructure in the real world. So the internet is a way to transport data between computers, and much like the real world, we have the transportation infrastructure. We have roads, we have airports, we have ports, we have train stations and trains and train tracks, and we are able like to transport things and people and products all around the world. So in the real world, the internet is kind of like this transportation infrastructure that humans have built over centuries, and we are able like to travel around or just transport things around the world. So it's a very basic, low-level way to just get to transport things and move things around. The internet is, of course, a digital version of that, a digital, let's say, kind of like way of connecting digital devices and transporting data, digital data. We don't have like real, physical things. But that's a nice way to kind of like have an analogy to the real world. And in much the same way that using this basic infrastructure in the real world, having like a transportation layer, a transportation network, and being able to move things around and people around, we can build on top of this infrastructure and provide services. For example, using the transportation layer, we can build a post or mail service on top of that. We say, okay, we have the way to like move things around and stuff. So why don't we let people like write letters to each other, put them in an envelope, and then get these envelopes all around the world through airplanes and ships and trains and whatever, and cars and trucks. So people can communicate with each other by sending, writing letters and then, reading these letters and sending more letters. So in the beginning, we use the transportation, let's say, infrastructure to build the post office and then the post mail, service. So we had this idea of letting people communicate with each other using simple mail. And we got some rules, like we say, okay, you're going to write your letter, you're going to put it in an envelope, you're going to write the recipient address, the sender address, and then mail it, place it in the post office box, and then Some people are going to take this envelope and move it around, and someone else can pick it up on another place in the world. In much the same way, we do this on the internet. So on this layer, this basic like transportation infrastructure, the internet, this communication mechanism, we decided to build services on top of this layer. So we said, okay, why don't we do the same thing that we did in the real world? Instead of mail, we can have electronic email. So we decided to use this transportation layer and then move around data, but that data would be very specific. It would be what we call now an email. So an electronic mail. So you write your mail, your message in kind of like a digital document, and then you stamp it with some email address and recipient address and the sender address, and you send it around through the internet. So we use one layer of called the internet, and then on top of the internet we invented the email. So a service that is used on top of the internet. It's important to remember this distinction. There's a low-level infrastructure, just communicating devices, digital devices communicating with each other. And on top of that, we decide to build services. So one lives on top of the other. We cannot have an email service without the internet infrastructure. It's built on top of the internet. Much like we can only have mail, physical mail, if we have roads and ships, and airports and stuff like that. So in the digital world, we started, devising, services and coming up with cool ideas to use the internet and provide different services. So one of the first things that came up was the email, of course. Okay, let's use the internet to send electronic email. And then at some point, a guy named like Tim Berners-Lee, that was working at the CERN laboratory in Switzerland, had another idea. He said, okay, we have the internet, we can like move email around, but it would be nice to share documents with each other. At that point, it was like the research community, scientists, physicists that wanted to share like documents with each other, like academic papers, scientific papers. So they said, okay, we're going to build another service. At least Tim Berners-Lee initially thought of like about this idea, had this idea. Okay, let's start sharing documents with each other, and these documents would be like kind of like let me find a document here, document icon. So we have these documents, and we want to share them like from one, let's say, university and one computer, let's say in one university, with another computer, and maybe share more documents with more research facilities or universities. So the idea, this was like the original idea behind the web or the World Wide Web, to share documents between each other. On our devices, on our computers, we would have digital documents, and then we would be able like to share them with each other. So if there was a really nice academic paper found in Zurich, in the University of Zurich, I would go there, connect to a computer, read the document, read the paper, and learn something. And because in the academic world, these scientific papers and these documents have references to other documents, like most of the times a scientific paper have lots and lots of references to other academic papers or scientific papers. It's work built on top of the work of other scientists. So there had to be a way to have these references quickly accessible. So when I'm reading about a scientific paper and I have just connected to a computer in Pennsylvania, I want also to quickly go and read the documents that are related to that paper. Okay, this is based on the work of scientist A and scientist B, or a scientific team or a research team, elsewhere. So I want to quickly go and read that document or read a part of that document. So there had to be a way that when we're reading a document, we can click a link, we can click a reference to another like document, and quickly open up that document in our computer and read that. So that was the whole idea behind the web. Have a software that would allow us to read the document, and within that document there will be references or links to other documents. And when we wanted to like open up these documents through our computer and through this software, we would just click a link, click on that reference or on description or like a keyword, and immediately we would see that document in our screens. So that meant that the software would have to connect to some computer somewhere in the internet, get the document, download it, and display it on our screen. This basic idea is how the web started and how we got to have the websites and the web pages and everything that you see online every single day. Very simple idea, but very powerful. And as you might guess, it's something that really changed the world. So on top of the internet, Tim Berners-Lee had to create software, a software that would allow us to see these documents. So I want to open up software and have something like a reader, a document reader. Um, so there had to be a software that would allow us to like display and read these documents. That software would also allow us to click these links and then load almost instantly other documents within that same software. I wouldn't have to leave this software and go open up another application, or I don't know, even go to another computer. Still using one piece of software, I would click a link and read another document and get another document and get another document. So Tim Berners-Lee had to build this software. This software eventually got the name web browser. So this is how the browser was invented. And then he also had to invent another part of the equation, uh, which was to be able to find like something of a standard or a protocol or some rules, so that this software could communicate with other computers and download the document. So there has to be some way to actually communicate this data and send these documents all around the web and download them. So apart from the software, he had to implement and think of a way to communicate within the internet and download to these documents. So the web eventually became a software where something that we call the web browser that would allow us to read these documents and download them, and then some kind of protocols, as we call them, some kind of rules through which we could like communicate and send these documents around. Um, Let me see. So I see a question, so let me stop here. So the question is by Leon. When we want a document to be registered at a national service in real world, we go to the protocol and get a signature. And after that, we get the signature document to the employee to register it to the database. Is that similar to how an internet protocol works? Well, not exactly. Well, actually, in the internet world, or in the computer world, when we talk about protocols, we talk about a set of rules. So I think a better analogy to understand what the protocol is in the computer world is to think about the rules that we use in order to send a mail in the real world. So what rules do we apply whenever we want to send a mail in the real world? The first rule is get your letter and put it in an envelope, or get, I don't know, like a present, a gift, and wrap it in a package. So that's a rule. That's a rule that's has to be applied all around the world. You cannot just go somewhere, in Japan, or I don't know, New Zealand, or wherever, and do your thing. You have to follow the rules. This is what the protocol is. Follow the first rule. Put your mail in an envelope. Put your thing in a package. The second rule is you have to put your sender details, which means name, address, city, country, and zip code. And these are very strict rules. It has to be in that order. It has to be like in English, for example, whenever you're going to send this abroad. And it has to have a very, very specific format, like the zip code. The zip code is, a number that's X digit long and stuff like that. So these are the rules that govern the post mail. And this is what I want you to think about protocols. So protocol is just a set of rules that we set in order to have a service, around the world working, or have something, in order and work in a very specific manner. So protocol is more closely related to this set of rules. So think of this as the rules that we use to send real, physical mail. Recipient address, sender address, specific order and format of this address, specific place in the envelope. this is the protocol. These are the rules. Here is the recipient, here is the sender, here is the format. Very strict rules that are applied and are used by every single like post office around the world. This is a protocol on the internet, a set of rules to which we have to adhere in order to use some kind of service. So it's more closely related to that instead of the more like bureaucratic, let's say, protocol process that you described, Leon. Um, so keep that example, I would say. Another question: can you repeat the names of internet layers and what is their level through a diagram? So I'm using like an overly simplistic view of the internet at this point. So I just mentioned like the internet layer, roughly representing like the way computers are communicating with each other, are connected with each other, and they're communicated. This is like very, very complicated. So behind this diagram, you'll find satellites. You have like cables, like underwater cables. You have like laser beams. You have like fiber optic cables. You have like all sorts of like wireless and wired connections between countries and continents and computer systems. So it's pretty complex, but at a very basic level, you can think of it as like the connection layer, just a way to connect computers together. That's the basic, let's say, low level, the internet. And on top of that, I only mentioned about the email layer, which is just a set of software and rules and protocols that we use on top of the internet to send electronic email. And the other layer, let's say, that I mentioned is the web, which is like a layer built on top of the internet, which means what do I mean by a layer? I mean software, specific software that is able like to read these documents, software that is able to share these documents. I'm going to go through this in detail in a few moments. And of course, a set of standards, a set of rules, a protocol, the web protocol. So how are we going to send this data? We need some rules. Do we need to use recipient data or address, sender address? How are we going to pack these messages, these documents? How are we going to send them across the globe? There's very specific rules that govern this web protocol. Um, and at this moment, I want to mention like a very, very important aspect of the web, which is that whenever we're dealing with this concept of the World Wide Web or the web, we have like two participants, two roles in this layer. We have the people and subsequently the computers that share the documents. For example, tomorrow I decide to publish an academic paper on like the internet, let's say, infrastructure. So on one hand, we have someone, a group of people or a person that decides to publish like a document, right? And they need a computer to upload this file in that computer and let people around the world connect to that computer and then download and read this document. So one part we have what we might call like the publisher, the people or the group of people that share the documents, and we have another role in this equation. Let's say the people that are consumers of these documents, the people that just want to read, to download and read these documents. So we have this kind of like publisher, reader, or consumer, or in terms of the web, we are calling this the client server relation. So we have client. So let's make server client. So whenever we have someone that wants to publish a document, these days the documents are websites, right, and web pages. We create the web page or the website, and then we upload it in a computer, and we let that computer be open, connected to the internet 24/7, so other computers can connect and download and read that document. So we call these computers servers. So for example, a server might be, let's say, this computer here acts as a server, and it has this document available online all day long, and people can connect through their mobile phone, through their laptops, through their desktop computers, through other devices, download the document and read it. And these are the clients. So we have, for example, this like device which is going to connect to this computer, the server. Let me. Okay, I cannot go inside this box, but you get the idea. This client connects to this server, downloads this document, and then uses a web browser to actually like read the document, either on the smartphone, on the computer. So the document is downloaded from the server to the client using special software called the web client or the browser, the web browser. And then that document, of course, is displayed in a nice way with pictures and content and colors and all this stuff. So this is like a basic idea of what the web is, some software and some rules, so that we can share some digital documents between devices and between like people in general. We use a software called the web server to store and share these documents. So we have different types of servers. For the web and for web documents and websites, we use the term web server. Is a specialized server that shares web documents. These documents are created using the languages that we just mentioned in the welcoming section. So we use these three languages to build these web documents. HTML give us the structure and the content of the document, the text, the images, the video, the audio, some kind of like basic layout, like structure, like headings, subheadings, paragraphs. We use CSS language to style and decorate this content to make it nicer, give it a nice look and feel, add some colors, add some nice like typography. And then we use JavaScript, which is a programming language, to actually add interactivity to these web pages. So instead of just reading a document, we can, interact it, with the document, click around, play a game, fill in a form, run some, fill in a form or do whatever we can or we want to with that document. So part of the web are these three languages which are used to build the web documents. So apart from the web server, apart from the web client, which is of course the browser, or one type of a web client is the browser. There are also other web clients. The most popular one, the ones that we use every single day, is the browser. So apart from the web server, the web client, we have these three languages that are also part of the web and they are used to create these web documents. Feel free to like raise your hand if you have a question, so we can pause for a bit and answer your questions. So just now, I said that in order to create this layer on top of the internet, this web layer, and have this web service running in our devices and then do all this cool stuff, we need the software, we need the web server software, we need the web client software, we need some computer languages to build the web documents. But we also need some rules to send this information around. So when a web client wants to connect to a web server, it has to use some set of rules, put the request in an envelope, put the recipient address, put the sender address, put the zip box, the zip, code and stuff like that. So we need some set of rules, the protocols, right? So the rules and the protocol that is that is used to connect the web server and the web clients is called the HTTP protocol. So this is the glue connects web clients and web servers around the world, right? So it's a set of rules, and we have software. Both the web clients and the web servers must adhere to this protocol, to the set of rules. They must follow the rules very, very in a very, very strict manner, so that we know that this request will pass through the internet, reach a web server, and then download the correct document and see it in our web client. So we must follow these rules. Otherwise, we might never reach a web server, or we might never download the correct document or in a correct format. So this set of rules that's connecting the web servers and then web clients, it's called the HTTP. Now, there's a lot of jargon in here: HTML, CSS, JavaScript, HTTP, client server. You need some time to familiarize yourself with these terms, and also, let's say, memorize them, or at least remember them. But one thing that kind of like I would like to note here is this HT in front of the HTTP and the HTML. So I'm just going to like decipher these two terms to see how they are connected with each other. So HTML stands for Hypertext Markup Language. Hypertext Markup Language. Kind of like a geeky term, which most of the times makes it difficult for us to learn things about computer science thing, because we have this kind of like awkward, let's say, jargon. So this language that is used to like create these web documents is a markup language. You will learn more about this markup language and why we call it markup language in today's and tomorrow's lessons. So that's just a type of a language, not a programming language. It's a markup language, which means it's a little bit simpler than a programming language. I'm going to focus on the hypertext part of this acronym. Why hypertext? So first of all, text, because we initially started sharing text, academic papers, scientific papers. What's hyper? Hyper is the Greek word for super. So you kind of think as super text. Why do we call it hyper or super text? Because apart from being a document where you can read stuff, so similar like to a paper document, to a document find in print or in a paper, it's super text because you can actually interact with the text. You can click on a link, on a reference, and then immediately you get to load and you get to see another document, another text. So hence the kind of like the jargon hyper. So hyper or super text was just a term that came up within like Tim Berners-Lee mind at that point, and said, okay, we have this text with super powers, with super abilities, so let's call it hypertext. That's what the HT is all about, like a super text, an interactive, let's say, text. So we got used to the hypertext. We use the markup language to build these hypertext documents. And then whenever we want to transfer these hypertext documents from a web server to a web client, we use the hypertext transfer protocol. So HTTP is just a way to transport hypertext around the internet. So hypertext transfer or transport, I think transfer protocol. So the glue between the web servers and the clients is the hypertext transfer protocol, a set of rules to transfer hypertext documents around the web. That's why we got these acronyms. I think if you break these terms, I kind of think them in this like more like a simple way, you can you can grasp like the basics of the web in a much better manner. So let's pause a bit and have some questions before we conclude with the front and the back end. Open up your microphones, raise your hand, and please ask any questions.
Of course, if anyone doesn't feel comfortable in speaking, he or she can type any language, any question in the message box.
Okay, feel free to raise your hand, and we can pause and we can have a discussion, which is always useful. Now, let me continue with like the terms that we need to know, front end and back end, because first of all, we're going to become front end developers, and second, we really want to decipher the term back end, which we're going to be hearing a lot. So this is very simple. I think going from this diagram and from this explanation to the front end and the back end, the terms will make sense to you. So whenever we're talking about the things that we see on the web client, on the web browser, so whenever we're talking about things that are in front of us, we open up the browser and we stare at the screen and we see the documents. This part, this front-facing part of the web, is what we actually call the front end, because it's these front-facing apps and the things that we read and we see and we interact. So this is called the front end. You might think of the front end as of everything that happens in the browser, if we want to oversimplify it. So front end means this front-facing part of the web. So HTML, CSS, JavaScript is used to create documents that we see in our browser, and hence it's front end. It's considered a front end technologies. And of course, someone that uses these languages to create websites and web pages that people can consume, can read, can actually see in the front end through their front-facing, let's say, interaction with the web, they are called front-end developers. That's what this course is all about. If someone is working on software that is running on the servers, not only the web servers, but all sorts of computers that act as servers, they serve other clients. These are called, so this part is called, no, sorry. Let me copy and call this here. We call this part of the equation or this diagram the backend, because it's something that is happening on the back far side of the web, of the internet, of some computer network. It's not happening in front of us. There's a computer in Utah, in New Zealand, that's sharing documents, that's doing, I don't know, something. And we only get to see the result of this far, computer when some information is downloaded on our web client and we see it through the front end. So something that's, let's say, far behind our front-facing interfaces and clients and browsers is what we call the backend. When you program a web server or you program a server, for example, a mail server, an email server, we talked about the email. There are also email servers. Apart from the web, we have the email layer. We have other, services and protocols. So we also have email servers, and we have quite a few servers, to be honest. So if you work on these servers, on these computers, on the software that runs on these computers, you are called the backend developer. And that's the distinction between the backend and the front end. During this course, we will be dealing with both the backend and the front end. But for the most part, I would say like 80% of this course is dedicated to the front end. About 20% is dedicated to the backend, because we want you to have a strong skill set and become really good front-end engineers and front-end developers, not back-end engineers. It takes years to become familiar and confident enough to work with both the front-end and the back-end. There's a lot of things happening, so we don't want you to spread your knowledge all around and do 100 things at the same time. Focus on one part, and where there's still a lot of high demand and a lot of job openings for front-end developers, even more than back-end, I would probably say. And eventually you will see whether you want to move a little bit closer and work a little bit more with the back-end development. And that concludes our presentation. This was like a high-level overview of, we covered the internet, we covered other services that are built and work on top of the internet, like the email services, the web, the World Wide Web. For the web, we talked about these web documents that are shared between web clients and web servers. We talked about the languages that are used to create these web documents, HTML, CSS, and JavaScript. We talked about the set of rules that govern the communication, the sharing, the transportation of these HTML and web documents, the HTTP. And then we gave a brief description of the distinction between the front end and the back end, and of course the the developer positions and the different requirements.